All right, number 52. Dev has a monthly food budget of $188. He maps the amount of money X he spends each month to the number of food items he buys. What is a reasonable domain? So in this example, they are telling us that X is the amount of money that he is spending on his food. Well, he has a budget. He has a budget of $180. So he kind of maps out his food for the whole month. Um, and what is a reasonable domain? So the money he puts in, the input, will produce the food he's buying, the output. So when we think about domain, we want to think about his money, the money he's putting in. Um, so for the amount of money, what would be a reasonable domain? So option A says the domain that X could be greater than or equal to zero. So I think that's partially true. I mean, you could spend no money on food that month, so it could be equal to zero. Or greater than means numbers positive, positive values, all of that makes sense for money. But what it doesn't do is it doesn't put a limit on this. So X is greater than or equal to zero tells us that Dev could spend an unlimited amount of money on food that month. And he has a budget, so we know he's not going to do that. So we're not going to choose option A. Option B says that the money he spends is greater than or equal to 188. Well, we know that his budget means he can spend up to 188, but he's not going to go over that. So we can't say greater than 188. Option C, the domain says X is less than or equal to 188. Well, I agree with that partially. You know, he's not going to spend more than $188 because he's budgeting 188 as his max. Um, but if we just say X is less than 188, that includes all the numbers that are less than 188, which goes into your negative X's as well. So can he spend a negative amount of dollars on food? He cannot. That's not reasonable for this situation. So I'm hoping option D makes the most sense since that's the one that we have left. So this domain says 0 is less than or equal to X is less than or equal to 188. So it kind of combines the two that I said I partially agreed with. Um, if we start in the middle with X and read it to the left, so read it backwards, X is greater than or equal to 0. So that keeps us from using negative values for X and saying that he could spend $0 on food that month. Maybe he has leftover food from the previous month. So X, his amount of money he's spending could be greater than or equal to 0. And then let's read to the right, X is less than or equal to 188. So this is saying that he's going to spend less than or equal to 188. He won't go above the 188, which is what is happening when he has that budget of 188. So this is the most reasonable domain, keeping in mind that um, dollar amounts will be positive, and he did have kind of a limit. He wasn't going to spend over $188. All right, number 53, Dev has a monthly food budget of $191 this time. He maps the amount of money X he spends each month to the number of food items he buys. What is a reasonable domain? So we just talked through this in detail on 52. So if you have a question on 53, I would go back and watch, listen to what I said about 52, because now that we kind of understand how to do this, this one is going to go quickly. So a reasonable domain, we're going to start at 0 so that our domain is our amount of money. We don't want that to be negative. That's going to be less than or equal to X, which will be, that's the amount of money he's spending on food. Less than or equal to, he has a food budget of 191. So he's not going over $191 in his spending. So that is the most that he will spend. So that is a reasonable domain for the situation. All right, number 54, a snail travels at a rate of 2.04 feet per minute. Write a rule to describe the function. How far will the snail travel in 7 minutes? So if you're traveling at a rate of 2.04 feet per minute, we're going to write a rule to figure out how far a snail can travel. So if we take the 2.04 and we multiply it by our number of minutes, so an X or a T for time, whatever the case may be, that will be a rule that describes it. So if we look at our options here, option A says 2.04 times T, that's what we just said. Option B says our time plus 2.04. We don't like that one. Option C is our time divided by 2.04, or option D is 7 times our T. So option A has the rule that we like, and then says the snail will travel 14.28 feet in 7 minutes. So we can just check that. If we plug in a 7 for that T, 2.04 times 7, that does give us the 14.28. So this is the rule to represent the situation and how far the snail will travel in 7 minutes. All right, number 55 is our follow-up question, very similar to what we just did. A snail travels at a rate of 2.59 feet per minute. Write a rule to describe the function. How far will the snail travel in 10 minutes? So I can just kind of model what we did before. Our distance that the snail travels in t minutes is 2.59 times t, our number of minutes. And then how far will the snail travel in 10 minutes? Well, if we just plug a 10 in for that t, so 2.59 times 10 gets us 25.9. So the snail will travel 25.9 feet in 10 minutes. All right, last question on this page, number 56. What is the effect on the graph of f of x equals 2x plus 1 when g of x equals 9 times 2x plus 1? So these are our transformations. When you are changing a function in some way, either with addition or subtraction or with multiplication, so what we want to do is just recognize, here's the original function, 2x plus 1. Do you see the 2x plus 1 in our g of x function? And how are we changing it? So right here is the 2x plus 1. That core part of it did not change, the function of 2x plus 1. But what we're doing is we are multiplying the whole function by a 9. So how does that affect our function, our new one? So if we were to distribute that 9, just to see what g of x would look like simplified, 9 times 2x is 18x, and 9 times 1 is a positive 9. So our options, we can see that f of x, the slope went from a 2x to an 18x, and the y-intercept went from a 1 to a 9. So option A, the graphs of g of x and f of x have the same slope. Well, that's not true because we just said this slope is 2, that slope is 18. The graphs of g of x and f of x have the same y-intercept. Well, this y-intercept is 1 and this y-intercept is 9, so we don't like that option. Option C, the slope of the graph of g of x is 9 times the slope of the graph of f of x. So is 18 9 times a 2? Sure is. And then the y-intercept changes from 1 to 9. So the y-intercept was a 1, and now it's a 9. So I think option C is the one we want, but let's just make sure we also disagree with choice D. The slope of the graph of g of x is 9 times the slope of the graph of f of x. So is 18 9 times a 2? Yep. And then it says the y-intercept does not change. So this y-intercept was 1. It did change to a 9, so we are not going to choose option D, which means we have a winner. C is the correct choice here.